Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we will ask the question, can the laws of electricity tell us the shape of the Earth? It is well documented that there is an electric potential gradient in the atmosphere that rises at a rate of 100 volts per meter in elevation from the Earth's surface. Now, knowing that alone doesn't answer our question. Instead, we will go straight to the man himself, former MIT physics professor of 4 decades, Dr. Walter Lewin.
So let's start the Van de Graaff. You can't see it, but I turn it on. It's rotating now. I have to put charge on here, so I'll touch it with the Van de Graaff. And so this is now charged. It has the same charge as the plane. The plane is being charged, and here you see the angle. Try to remember that angle. It's hard to estimate, maybe 15 degrees. You see the vertical. And if now it's about 30 centimeters away from the plane. And if now I go back to 50 centimeters, which is where I'm now, you see the angle hasn't changed very much. If I go further out to 60 centimeters, yeah, the angle goes down a little, of course it does, but not very much. And if I go far away, all the way to Mass Avenue, of course, the force on this little object would be inversely r squared, because then the whole plane would behave like a point source. So I've shown you that very close to this plane, the electric field stays approximately constant. Oh, it is already charged. Okay, so look at the projection. The balloon is now, maybe 30 centimeters away from the center, maybe 40. Oh, the angle is almost 45 degrees. And now I double the distance, I go to about 90 centimeters, and look at that angle theta. The angle theta is now down to, maybe 10 degrees. I will go back where I was. This angle is about 40 degrees, and now it's very small, and when I go here, which is about 1.5 meters, you can hardly see that there's any angle. It's only a few degrees. And so I've shown you only qualitatively that the electric field falls off very rapidly in the vicinity of a...
As you heard the professor state, the electric field on a large flat plane will weaken more uniformly or evenly until it gets far enough away as to where it starts acting like a point source or a sphere. When the electric field of a sphere weakens, it does so at the inverse square law, much faster than that of the plane. Now this should bring up some new questions when we comprehend what we are being taught. Is the electric field of the Earth mistaken about what shape it is permeating from? Are the electric field measurements of the Earth being measured incorrectly? Are the laws of electricity that we have created many amazing technologies with wrong? Or are the measurements correct? The laws accurate? And the shape mistaken? This is Good Times for All signing out. As always, thanks for watching.